everyone, welcome to our lesson on solving quadratic equations using factoring method. Today, we're going to explore factoring method to solve these equations. By the end of this session, you'll be confident in tackling factoring method and quadratic equation that comes your way. Let's get started. First, let's understand what a quadratic equation is. It's any equation that can be written in this standard form. ax squared plus bx plus c equals 0. Here, a, b, and c are constants, and x is the variable we want to solve for. Today, our learning goals are: first, to understand the standard form of a quadratic equation. Second, to learn how to solve quadratic equations using factoring. Let's start with factoring. A method that involves writing the quadratic equation as a product of two binomials. For example, let's take the equation x squared minus 5x plus 6 equals 0. We can factor this into x minus 2 times x minus 3 equals 0. Once factored, we solve for x by setting each factor to 0, giving us x equals 2 and x equals 3. For the second example, let's use the same method and it is factoring. Let's factor x squared plus 2x minus 15 equals 0. We can factor this into x minus 3 times x plus 5 equals 0. Once factored, we solve for x by setting each factor to 0, giving us x equals 3 and x equals negative 5. Now, it's your turn. Try solving this equation. X squared minus 7x plus 12 equals 0. Pause the video if you need more time and come back to check your answer. Quadratic equations aren't just theoretical. They have practical applications in many fields. For instance, they are used to calculate the path of a projectile, optimize business profits, and even design structures in architecture. Understanding how to solve them equips you with tools that are variable beyond the classroom. Let's test what you've learned with a quick quiz. Solve these quadratic equations using factoring method. Take your time and pause the video if you need to. Now, let's review the solutions together. Make sure to correct any mistakes and understand where you might have gone wrong. To wrap up, today we covered how to solve quadratic equations using factoring method. These methods are crucial for many mathematical applications, and with practice, you'll become proficient at using it. Thank you for joining me today. If you have any questions, feel free to reach out. Keep practicing and you'll master quadratic equations using factoring method in no time. See you next time! As you learn in Addie's model of how to factor quadratic equation, let's apply it in Bloom's taxonomy. Before we move forward, let's take a moment to review what we've learned so far. Can you recall the standard form of a quadratic equation? What do the coefficients a, b, and c represent in the equation ax squared plus bx plus c equals 0? Think about where you've seen quadratic equations before. Can you remember the steps involved in factoring a simple quadratic equation? Now that we've recalled the basics, let's deepen our understanding. Why do you think the quadratic equation is written in the form ax squared plus bx plus c equals 0? How do the values of a, b, and c influence the shape and position of the parabola on a graph? What does it mean for an equation to be factorable? Understanding these relationships is key to knowing when and how to apply different methods for solving quadratic equations. Now that you understand how to solve quadratic equations using factoring, let's apply this knowledge to a more challenging problem. Here's a question for you. Given the quadratic equation 2x squared minus 8x plus 6 equals 0, How would you factor it and what values of x do you find? Think about the steps you would take. How does factoring out the greatest common factor first affect the rest of the problem? Let's analyze different types of quadratic equations. Here are two equations, x squared plus 4x plus 4 equals 0, and x squared plus 2x plus 5 equals 0. How would you decide whether each equation can be factored easily? What characteristics help you make this determination? After deciding, evaluate. Which method would be more efficient for each equation, factoring the quadratic formula or completing the square? Why do you think so? Now, it's time to evaluate your understanding. Here are a few quadratic equations and word problems. Which methods would you use to solve them and why? How would you justify your choice of method in each case? Once you've completed the problems, think about why you choose specific methods. How could you apply these skills in new or different situations? Let's put your skills to the test by creating and solving quadratic equations for real-life scenarios. Imagine you're tasked with designing a rectangular garden with a fixed perimeter of 40 meters. How would you create a quadratic equation to represent the area of the garden as a function of one side's length? What would the equation look like, and how would you use it to maximize the area? Now, think about other situations like predicting the path of a projectile or optimizing business profits. How would you create and solve quadratic equations to find solution in these contexts? As we conclude, let's reflect on your learning today. How can you determine the best method for solving any given quadratic equation? And what types of real-world scenarios might you create and solve quadratic equations? How has understanding factoring enhanced your problem-solving abilities? Think about this equation as you continue practicing. How will you apply what you've learned in the future challenges?